Welcome to BoneChat discussion number 50. Today we have Doug Fairbanks. I was a big fan of Doug actually before he took the helm at VIsie, and then once I learned about VIsie and what they're doing, I fell in love with VIsie. So they're creating a technology that I think every robot and navigation system in the world needs, but they haven't figured it out yet. So Doug, welcome aboard. The mic is yours.
Yeah, thank you. For correction, I think we figured it out. Now, can everybody else figure it out? Is the answer? But I'm very pleased to be here. Like Tiger mentioned, Tiger and I really had a growing relationship in the time before I came to VIsie and then became CEO. And actually, Tiger helped me hire one of the best employees in the organization. And that continues to bear fruit for us as a company. So we're excited to be here. As a point, I'm very open to discussion. So if you have a question about anything that you see or something point in time, I'm happy to answer it and to stop me anytime and go ahead. I'm going to give a presentation that's eerily similar to what happened at MMVC. So some of you are familiar faces there. But I will go ahead and switch over and present my screen. You let me know when you see the right thing here is my, does everybody see the, there you go. Good. Okay. So VIsie is a deep tech spatial computing company, and that's it's a word salad a little bit, right? Really what we are is a technology that's operating kind of on the edge of what is scientifically possible, and we're really giving spatial awareness to these technology systems that are becoming more and more a part of our day-to-day. And I'll tell you, I start every conversation and end every conversation with a talk about surgeons. Surgeons are our customers. We're very deeply interested in what surgeons want and what they need, and I think that's a winning strategy for us as a company to say, hey, are we solving a problem? I will also tell you that we pay unique attention to experience, and I'll talk a lot about experience in this, not the experience of the team, although that's valuable, but when someone interacts with our device, what is the interaction doing for them, and how is it making their lives better? So that's a little more lead in than I usually start with, but here's a Bain & Co study from 2022 that said 89% of surgeons were interested, and orthosurgeons were interested in using robotics, while 51% had adopted. Now, there's a huge gap between adoption and interest, and there's any number of reasons why that gap might exist, either through the cost of the systems, the learning curves, any number of things. But what it does speak to is that there's a growing interest in surgeons making decisions about their procedures based on the technology to do them. It used to be that we'd pay very close attention to the curvature of an implant, or the features of it, or even the surgical approach, anterior or lateral approach, right? And then we seem to be in this era where part of the decision making, if not a very large part of it, is based on the technology used to put it in. And when we think about that technology, we get this experience of putting pins and arrays into tissue so that the technologies can see where the tissue is, where the bone is, right? And then that requires that we do a registration process. And many of you are familiar with this, but you take points on the anatomy. And in this conversation, we primarily focused in total joint replacement, but there is some spine material, and that communicates back to a system. Now, when I think about this process, I actually think about my father. My dad went to go get his partial knee done several years ago, and he said, Doug, what kind of surgeon did you send me to? He operated on my thigh and my ankle. What's wrong? He couldn't find my knee? And we chuckle about that and say, well, you actually went to one of the most famous orthopedic surgeons in the world, Dr. Headley in Phoenix, and has since passed, but phenomenal surgeon, and did a really great job for him. But you think about that experience, and that's a bad experience for the patient. It's also a bad experience for the surgeon. The surgeon doesn't want to do a bunch of extra procedures and doing a bunch of extra registration. And the challenges associated with it go beyond the anecdotal, that there's tons of literature that point out that the use of these technologies, result in pin site fractures, infections, The learning curves are very high. And the FDA actually issued a warning that says that these tracking technologies can result in patient death, life-threatening injuries, failed, aborted, or prolonged procedures. And that's pretty impactful. Now, when we think about what this is, you and I see a bone with a couple percutaneous pins and arrays, but we have to think about what the computer sees. What the computer sees is this, a couple of dots in space. And when we think about the power of data and information and how often we talk about the use of data, we realize that there's very, very low quality image data associated with these procedures, that essentially a couple of glowing spots in space tell us where the tissue is or where the bone is. And at VIsie, what we're asking you to do is to see the problem that everybody ignores. And in fact, what we're saying is it's time to see the patient. Here's a single scan out of a scanner that we invented, 1 million data points in a fraction of a second. Size, scale, color accurate, right? The computer can now see the tissue in the same way that the surgeon does. And we're excited about this. We invented this new way of three-dimensional scanning, and so we can change the embodiments and size and form factor. Here's a number of ones that we've looked at and continue to play around with as we work through in the company. And we've gone to solve some bigger problems. Here's a scan that is done in infrared, the knee, right? A single scan of a knee in infrared that gives us data that doesn't disrupt the room OR lights. It's not disrupted by turning the lights on or off or the glow that happens in the room. Here is an anterior hip scan done, quite frankly, with the device not developed for an anterior procedure. And here we caught this very small female with an anterior approach, caught the bottom of the acetabulum, and had enough data to superimpose a preoperative image. It was this image that won us the Anterior Hip Foundation's Shark Tank, and 150 surgeons stood up and applauded us for solving this problem of putting pins and arrays in the patient to be able to know where the tissue is. Here's a glenoid. In the size of a $50, we can grab 12 to 14,000 data points. Easily enough data to create a superposition to the preoperative image to allow your tissue to be able to understand your computer to see what happens in the procedure. Here's a pig, 6 to 8 inches of adipose tissue in the office. We take a single scan, catch the side of the lamina, and boom, bring in the preoperative image. So being able to see where things are without radiation, without delay to the case. And it's fine. We think about moving down the segments. As you move down the segments or touch another segment, you introduce motion. And in fact, that's the goal. And so how do we know where those pieces are and make a meaningful connection to the tissue? And when we go further than that, we think about the ideas and concepts around registration. Right now, registration requires trace, where you take, on a femur, maybe 40, 100, or 350 data points. And that could be done in a minute or a couple minutes. Again, in a fraction of a second. 376,000 data points, orders of magnitude more precise than trace, right? And is objective, not subjective to where the surgeon decided to choose the point. And so last year at Academy, we did this, at AUKUS, we did this. We mounted a scanner robotic arm. We said, register the patient, then drive to a cut plane. And it did. I'll take you back through it. You see it very quickly here. But it's going to go to the anterior cut plane, it'll go to the distal cut plane on the femur, and it'll do automatically. Now, we're not moving towards an automated answer, but we're saying, hey, look, the tissue without pins and arrays can be seen and can be registered and we can make sense of it. We developed our own IP here, and we filed it around the world. We are this week loading and sending through another tranche of IP. We can continue to develop and file IP. And we've done that globally in really strategic markets. We're really excited about it. Our FDA pathway is through 510K, and it's really as a component level, which requires that we meet the 1345 and the 60601 testing. Go-to-market plan is through partnerships to gain market access to sell software and hardware and disposables. We're really excited about surgeons, and when we talk to surgeons, the response is very strong. I was at MMVC, and I had a line of 9 to 12 people, and that's honestly typical of our presentations. People line up to say, how do they be more involved, or how they understand the company, or how do they participate more actively. But when we talk to surgeons, they say things like simplifying image registration would be huge. We need robotic systems that save time and tissue. Pinless robotics would be the holy grail. Pinless robotics would be the holy grail. So I'm excited to come here and to continue to share the special things that we've done as an organization. And when I talk to the engineers, they describe something that they call technical feasibility. And when I have the marketing people say what we've done, they say, well, proof of concept. But when I talk about it, what I think we've done is seismic. It's huge, a big change. And that is continuous anatomic auto tracking. The ability to not only see the tissue in a snapshot, but to continuously see anatomy and use that to track where the procedure is going. Here's an image of it. Here's Dr. Andrew Fisher, a PhD biomechanical engineer we have in the office. We have a scanner mounted to the end of a KUKA robot. We're not a robotics company, but we happen to learn a skill to program a robot. What's happening here is really special. It looks simple. It is not. Dozens of times a second, this scanner that's covered by a blue dot here is looking at a knee. It's saying, I know that's a knee. It knows how big it is, it knows how far away it is, it knows what its makeup is, and it's saying, I'm going to follow that. And on top of it, to make the problem harder, we've mounted it to a robotic arm that's moving. I use the analogy, taking a picture of a car as it speeds by is pretty easy. Taking a picture of a car as you are driving with your head out of the car, holding a camera and steering the wheel, and driving next to another car is much harder. And that's essentially what the team has done here, is essentially drive a robot while scanning the tissue and using it to get to a position. And so we asked, what's the impact of that? And the impact is, sorry, the video is getting caught up here, is pinless robotic assisted surgery. The ability to not do those little surgeries outside of the patient, to be able to operate on them. To let the computer that you rely on for data to see the tissue the same way that you do. And we think that's impactful. So we're really excited about the team. I actually am not a huge fan of this team because it tends to focus on leadership, and really the people who are making this happen are the engineers who show up every day and push the very edge of what's scientifically possible. And we're really excited about the things that we've achieved. We have a number of surgeons that work on a consulting board with us. We've won a bunch of awards. It's exciting to reap the benefits of the awards and to be seen. We're in the NVIDIA Inception program. These are great, but the team is really focused on the big reward, which is treating our first patient. And we're barreling headlong at that. So at VIsie, I'll leave you with, at VIsie, there's more to see. I encourage you to all go to visievision.com or to engage with us as meaningfully as you can to help us make our dream a reality. That's my presentation. I'll maybe show one more video because I just probably have one right off the press here, and I'll stop sharing while I do that. And I'll open it for questions, and then I probably have a couple questions that I want to send to all the experts here on the call. Sorry. There you go. Tiger, any thoughts?
No, this is fascinating. I mean, I think everybody's wheels are turning, like trying to figure out. So how many times a second do you automatically register now, and what's the goal in the future?
Yeah, so we are. Well, I'm not going to give a direct answer there because it's, first of all, it's in flux. We gain speed every day. That's the big thing, is that getting to a speed that's tangible for the robotic system that would be integrated into. That being said, we're at dozens. I think that you watched a video just now at 25. It just so happens that the human eye perception is about 24 times a second. So if you go much faster, you're actually going faster than you need to go for people's perceptions. There's like video gamers that can see faster than that, but they're trained for it. But yeah, we are, I think, above human perception standards and moving into places that are even faster for robotic systems.
25 hertz. And I remember the old television interlacing used to be, I think, 30 hertz or something like that. So yeah.
Yeah, and we have 30 on the radar. We're not quite there yet, but we see a pathway to 30.
All right, Asher's got the first comment or question.
Yeah, a quick question. Well, and I apologize if I missed this. Why'd you guys start with knees instead of spine? Just out of curiosity.
We've worked in spine. We actually had done more work in spine before knee. It's an optical scanner, so it has to see the tissue to be able to execute on it. So open procedures are more compelling to us. So knee is very, very good for us. Shoulder and hip are interesting. Spine is a little bit deeper down, and we're working into formats that we believe will be more compelling there. But it just so happens that the market in knees for this technology is much, much larger. Is that fair?
Yeah, that makes sense. I was thinking more at it from the perspective of open scoliosis surgery, which is really where the majority of surgeons who have adopted robotics in spine go. You're right. In terms of the percutaneous market, it really doesn't seem like a good fit, but that's a good thought. Thanks.
And actually, that was a good comment, because there are some players that are working on optical registration only. Now, we're registration, and you're seeing tracking now. And the other players that are in the space tend to all be in spine. You see Pathkeeper, Proprio,
Yep.
And some others.
Yeah,
70,
that's exactly what I was asking.
70. Yep, 70.
Cool. Good, great comments. Mauricio and then Ted.
Great product, great idea. I'm almost kicking myself I didn't think of scanning the surgical field in 3D. I play with 3D scanners. I have one at home, so it's just, yeah, I feel like I should have thought of it. But anyway, I'll give you a quick story, a quick pitch. We have a 3D platform for like surgical planning. So we've created a whole cloud-based thing where you upload your CT, we auto-segment it, and it gets visible for the planning process. And I have like a ton of CMF indications where maybe not for robotics, so it could be an easier pathway, but for surgical guide positioning, I think this would be an incredible tool. So I would love to discuss this further.
Mauricio, I will, first of all, happy to talk about segmentation. It is a need that we have. We are very clearly trying to stay in our lane. So people asked about segmentation, asked us about other things. We said, no, we're there. And I'll even go a little bit further, that we're not just a robotic solution. What the company does is it solves the very hard problem of connecting the technology to the bone or the tissue. And that's agnostic. So that can be embodied into AR/VR glasses, into navigation systems, into robotics. It just saw that there was an arm with a robot on it, but that arm is not actually part of what we bring as value to the company. So I'll touch on those pieces. The other pieces, yeah, we absolutely do think about 3D, and we're interested in there. And so I'm happy to connect at some other time to see if there's any synergy.
Yeah, that's awesome. Thank you.
Good stuff, Ted.
Yeah, Doug, great. I'm glad I was able to catch this presentation this afternoon, because I was not able to see it in Memphis. But Asher really covered the question I had about the spine side of it, and that makes sense because minimally invasive percutaneous procedures. If you have to be able to capture a minimum amount of bone, it's not going to be the right fit, at least for that side of spine. The ASC type procedures, or where it's going with endoscopic spine surgery. So is there a possibility or a technology that could take your technology onto a chip on a stick, a tip type thing, if you get a minimal amount of through a cannula to be able to do the same thing? And then I have a follow-on question as an investor.
I'm smirking. My default answer when I don't want to answer is to smirk.
Yeah.
First of all, the company holds a lot of IP about a new way of 3D scanning. So that actually goes back to Mauricio's comments. Mauricio, we saw 3D scanning, and we actually had to get to very accurate and very fast, which is not an easy problem. So that's where we spent all of our energy. Secondly, Ted, I'll tell you that we do have thoughts or ambitions in spine and in MIS appropriate procedures. We do think that there is a scalability to the product. Is that going right now? They're still kind of early days there. I will tell you, I was actually on the call early with Tiger, and I said, someone had a quote about saying no to 1,000 things so you could say yes to the one thing that matters. One of the hard things in my role is all the really brilliant ideas that come here that I have to respond to as, hey, that is awesome. I see it. I want to do it. We cannot do it. And it breaks people's hearts because they're like, I have a great idea. And I agree, they're great ideas. So we have an MIS place in the business. We have a place where we're thinking about it, but it probably won't get to fruition until we achieve some of our near-term goals, if that's fair.
I completely support that philosophy. Yeah, particularly with a startup. Focus, focus, focus. So
There's
as
there's only so much gas in the tank, right?
Absolutely. So an investor question, where are you at from a capital raise, capital in, but capital raise and where you're going to go in the next 3 to 5 years?
Yeah, I appreciate that. So last year, 2023, we went out and put an A round together. 8.2 oversubscribed A round, $8.2 million. That gets us cash into late 2025. We are pretty capital efficient. We don't spend a ton of money. That gives us a fair amount of runway. I particularly don't want to get into a bind. We were in a rough spot and going to raise money. And everybody knows right now cash is tough.
Yeah.
It is a tough game out there. So we are glad to not be raising right now. And we had that done last year. In the next 3 to 6 months, we will pick up the torch in terms of what happens at the end of 25 for runway. And so I'm happy to continue to be transparent on the efforts that we're going to make there. It likely for us looks like not a B round, probably at the far end an A2, but more likely something like a note or something that rides with the company. So I hope that answers your question. I'm happy to continue to communicate, and we can sign you up if you want to get information about the company. We will,
Sure.
when we go to raise, start talking about it more publicly, if that's fair, Ted.
That's fair. And did I miss it? 510K approved yet? So you commercial
Not
traction?
yet.
Okay.
510K, not yet. We believe our best pathway is through essentially the component classification, which essentially means we have to meet the engineering standards, but then we'll be filed with the larger component. And I was going to let the questions clear out, but we'll hold on to that piece because I would like to just take the feedback of all the experts on the call on an element there. But Tiger, there are other questions that are lingering?
Nobody's asked the business model question yet. So you guys, you have a unique way. You could create your own devices, or you could license. Which direction you think you're going?
Yeah, and I think that this is, Tiger asked me to prepare some questions that I could bring to some experts, and I appreciate that. So I will do that now. My question is, and we think about this a lot, but really we have solved this really challenging problem. We don't want to be a robotics company. And I don't necessarily think that the value is standing up a standalone robotics platform. I think a lot of these companies have a robot to be able to put a moat around their business and secure the implant business as their real revenue driver. And in a market, and I give a good presentation, I think on YouTube is a pretty fun one that talks about the mid 1970s, mid 1980s, where there was hundreds of computer companies and only 2 had something really different. Apple with Lisa and Microsoft with Windows, where they thought about the user using a mouse to click on things rather than a command line to type in, and it made the computers way more usable, and they were rewarded for this. So I position the company as having something that really dramatically improves the patient and surgeon experience and is a tool to make your robotic system better for your customers. And I really want to zero in on that. So as a model, I'll explain that our business model is to integrate into other platforms to make this a reality in surgery. So that begs the question. It shortcuts the ability or the effort that you have to do to launch a commercial organization, but it requires that there's real intensive work right now from a BD element on our business to make sure we secure partnerships. And that can be complicated because in any startup, and a startup like this, an exit is critical. So when you think about strategies as it approaches, a company that has to be embedded, how do you follow through with partnerships in a way that facilitates a maximum exit? And that would be the question I have for the folks.
Great question. So how would you guys, a lot of smart people, how would you position this to license agnostically?
Yeah, can I jump in? So, Doug, my thought is, to be universal, at least at the first stage of that process. Think about another sort of robotics company, say Essential Robotics, for example. In spine, at least they've gone and kind of partnered with half a dozen, and probably there's more in queue, companies to apply their technology to their mostly mid-size or smaller companies to compete with the Mazors and the Excelsius with Globus and on their contracting basis. But I think my thought is it'd be important for you to just demonstrate efficacy and how the system works successfully and collect all that data by doing a few of those partnerships. Just don't give any exclusives away. And then you build that sort of momentum and that buzz until Stryker finally comes to their senses and gives you the right number, or J&J does, for the early investors. And so that would be my recommendation, is just, draw up a list. In this column, we got these 6 that we want to start working with, and those are going to be the best or easiest to work with. And we do a really good job within the company and perhaps with them as partners and collecting data and being able to continue to get the word out, up above the radar screen about how great this is and differentiated it is. But at the same time, keep your eye on the mission of, a legendary exit, but in the space, because you're not going to try and become a robotics company either. So kind of just build the momentum that way.
Ted, I really like that answer. And again, the smirking is because I believe that is close to my exact answer. But I think that there's another hand up there. I like it. Thank you, Ted. It's good validation. I think we are somewhat on that route, and I'm going to tweak that for you a little bit after we get some of these questions out of the way, because there's another interesting piece of this. Sorry.
Interesting. Asher?
So I don't know if there's a CPT code for surgeons who do navigated knee surgery. I know there is for spine, but if you're able to get a database of surgeons that use robotics in knee surgery at this time, then kind of working backwards to figure out what systems they're working with, and then targeting those companies maybe is sort of roundabout way to kind of get your customer or your end customer buy-in for the actual OEMs to understand the value proposition of this. If you're struggling with a strategic partner side directly, if I was a surgeon and you showed me this, I'd be all over this, because it seems like just an objectively better product than what's currently out there. And so even if the OEMs don't really understand the value, kind of working backwards or indirectly, maybe a way to kind of get them interested and kind of force your way into that opportunity.
Sure. I think it's a great idea. In fact, there was a tool that got acquired and called Carevoyance that I used to do a lot of data mining out of. They're now owned by H1. So I don't know if the tool still exists, but they basically let you search all the CPT codes. So you could even go into your city and say, oh, I'm in Austin, Texas, and you could see what surgeon was performing what and data mine that way. So I do like that approach. We happen to have a pretty strong surgeon investment pool that is very strong advocates of us and high volume, pretty well recognized folks. But I do think that when we show surgeons, they get on board pretty quickly, and I like that as an approach. We plan to do some of that next week at AUKUS. We have an offsite event to continue to drive it. You bring up something really interesting, Asher. CPT codes. There are a CPT code for navigation, which also has been applied to robotics in ortho. There is also something very interesting for us called OCT, called optical coherence tomography. It's not accepted for bony procedures, but there is an OCT code for eye surgery, we have a very close correlation to OCT. And so one of my efforts in the back of my mind, and I'm open to anybody having a thought on this, is to see what is the work that needs to be done to make an OCT code applicable to a spine or ortho procedure, because essentially improving reimbursement would be a value add that is significant.
Yeah, that's a great comment. I mean, obviously I'm a little biased. I would avoid getting into the space of trying to create your own CPT codes. I know there's a lot of companies that are doing that. It is a slugfest of work, and it takes millions of dollars and years of collecting clinical data. And then, if you think about it, you're basically taking away reimbursement dollars from other, categories to be able to allocate to your novel code. If you're able to make it work without it, personally, I would highly recommend that. But I know a lot of companies are pursuing novel codes just for scalability.
Yeah, I'm surprised that I saw somebody get one the other day, and it surprised me because I know that it's a rigorous route. Thank you for the feedback.
Yeah, you're gonna let your partners do that part. What do you need to do the first surgeries next year, other than a FDA clearance?
Yeah, we think that there's also a possible route to get a lower classification as a class 1 device. It's a camera, so not real risky to patients. A sterile drape actually is more risky. But we think that we could even jump through a hoop and get a class 1 device pretty easily and take this and start scanning patients and start building a database of optical scans to be fed into AI tools, which is a route and a business opportunity in the company. We don't play that hand very heavily because I feel like everybody has to talk about AI. We have an AI play. We don't work it too hard. But the securing of a partnership, and I'll take Ted's lead here, is critical to our business. I think going downstream to a lower tier player and dictating the terms of the relationship is probably the best or bailout route alternative to not securing one of the biggest companies at the table.
Good. Cope?
Hey, Doug. More a question of back to in the operating room workflow associated with this. What's it look like?
We're hoping much better. We think about all the steps that take place to get to a surgery. So we showed that knee, but you walk in as a surgeon. Okay, I'm gonna put the pins in the patient. I'm either gonna extend my arthrotomy to put the pins inside the wound, or I'm gonna do some stab incisions above or below to put the pins in. So I got to put pins in the patient. I then have to close those little sites, right? I got to hope or pray that I don't have a pin site fracture. I got a guy in Los Angeles. He said, Doug, I do 500 needs a year. I know 2 patients' names. You know why I know these 2 patients' names? I got a periprosthetic fractures from the pins on 2 patients, and I'll never forget what a nightmare that was, right? And so, look, not extra incisions, not extra pins in the patient. Also, not the time to go and register this point, this point, this point, this point, this point, and then all the instruments and disposables that are associated with that. We still have a disposable component, and that's critical to us in our business. But we're not going to have those pins and arrays and potentially one less tray for instruments to be able to do those parts of the procedure. So the experience, we think, is enter the procedure, do the arthrotomy, point the camera at the patient. The camera knows how big the tissue is, knows where it's at. You say go and go. And I, in fact, think we have an opportunity in the next couple of months to even do a small clinical study that says we can go from our end of arthrotomy to first cut plane faster than mechanical instruments, and certainly faster than any robot in the market.
Thanks. I sold apparently the only 7D in the state of Pennsylvania, and we were just using it this morning for spine, obviously. It's a really cool system, and workflow is pretty easy for the surgeon, but we see more Excelsius robots and stealth systems sitting in corners because of the business model where the reps don't want to do it. The company won't send anybody in, and it's painful to set up and take down. And I don't know that I have much of a comment other than caution on the setup before the surgeon walks into the room, because it'll end up if it's a lot, it will end up being back on your team no matter what anybody else tells you. And there's costs and expenses and investor money associated with that is astronomical.
Yeah, not to
It's
mention
sort
that.
of interesting, and because they and 7D experienced it, because they're experiencing it still, even though they were acquired by C-Spine, because they were agnostic originally, and they couldn't get any orthopedic or spine rep to want to learn how to do it to try to get business for surgeons. I really don't understand why that's a whole different discussion, but it is like a cautionary tale to be
Yeah,
preactively.
I get it. Yeah, and I think it's a good one, Mark, and you know, making sure that these systems are supported is a key element of the equation. Now, I'll tell you that we've actually done some things to reduce the burden of the setup, right? And so you think like when someone does a robotic procedure, somebody's got to come in and tell the robot where it is in space and program it. You know, we've taken considerable steps to reduce that burden so that it is easier to, but I think some of these business model things actually correlate back to the company supporting them. And by the way, I did the orthopedic business turnaround for Brain Lab years ago, but when we think about it, when you walk past the system in a hospital and it's not getting used, there is no worse feeling for the hospital administrator who really had to work hard to buy that system. Now they got to walk by it, and every time they curse the person who got. So the business is not just not good to be using your implant. Everybody walks by and curses you as they do it. So I'm with you, Mark. Good thought, and I think important to us. And by the way, I think that's part of where we are different from other folks. You know, everybody at a lot of these meetings, everybody's talking about new and innovative ways to treat different things. What we're saying is there's better ways to do the things that you're already doing. And surgeons' experience matter. If it's easy for them to use, they're more likely to use it. So that might tie back.
Yeah, I'll speak for David Kay. Dr. David Kay is not on the call today, but he's preaching over and over that you have to reduce labor in the operating room, and you have to at all costs. Anything new has to reduce labor. And so I would quantify it as much as you can, Doug. You know, is it 5 minutes? Is it 10 minutes? Is it a, you know, one more circulating person that's not there, whatever.
Yeah. I think that's part of the value analysis that we're doing right now, is to say, you know, how do we improve what you currently have? But I think that and by the way, I don't want any of these to come off as claims. We're still pre-market, we're still pre-FDA. I'm assuming everybody on this call gets it, but these things, you know, we are seeing that an improvement is certainly attainable through the technology.
So Mark Maloney is driving, and he sent a text. He's got multiple startup companies. Mark's incredible. He said he's got one of his companies has software that can search a surgeon list and identify who is paying them as consultants. So if you want access to that, Mark Maloney can point you to that.
I appreciate that, Mark.
Yeah.
So that's interesting, Mark. Better than the government reported sunshines. So there's a lot of small companies out there that probably aren't reporting. Maybe your software is picking up on that.
What quarter, Doug, do you think you're going to do your first cases?
Right now it's tough to know. We are very eager to get going inside of the first couple months on some bigger projects, first couple months of next year on some clinical applications. We have a big kind of event at AUKUS to show the technology to some strategics, but our effort is to start turning the key on the go-to-market product in early next year. And so I can't say if the process is a big one or a small one from this outlook. We tend to move very quickly. We set very aggressive milestones, and honestly, to the team's credit, they accomplish milestones often ahead of time. And so it's really great to work in an organization that shows up with the output. And I'll tell you, in the last couple of weeks where I've been talking about this technology, the reaction that I'm getting more often than not is, "Hey, you said you were going to do this, and then you did it." And I'm surprised that that like rattles people, but that's what we're into. We want to set the goal and we want to hit it, and people are taking notes, so it's good for us.
It actually indirectly drives the valuation of your company. When you say what when you do what you say you're going to do, that is really impressive. So keep up the good work. Eric, you got any comments? Or John, Andrea, you guys are kind of quiet.
Yeah, I
Anybody?
mean, the one thing I thought about when you were talking about, partnerships and as you're at such a forefront of this incredible technology, to really pay attention to the context writing or even the development community. There's few companies need to such new ideas come through that you have to set up because that's just like licensing something that we work with this model that will be vital as well as undergraduate part and sure John is advising properly on that front. And even though you're saying that you're not going to get into this for a while as someone mentioned that the minimum usage is fine and so such finding this provisional application early on just to be sure that no one else is like, you see the small group of people and you need to start brainstorming. I know it's budget intensive, but if you're not doing it, someone else will.
Yeah, I think there's two kind of takeaways there, and on my side it was a little bit muffled there, so I apologize. But kind of two pieces that I'll take away is A, be careful about the partnerships and how those contracts work. Yeah, we are very meticulous about those, and we agree it's a critical step for the organization to be able to make sure that they have the flexibility in contracts. It's funny that everybody wants to ask for exclusivity, and sometimes people are offended. Oh, they're asking for exclusivity. No, that's good. Of course they're going to ask for everything, and some of these people are known to ask for everything. But that's one piece of this. We did take a pretty big turn on IP. About 3 months ago, we hired the former lead of IP at VIsie during their kind of acceleration time in the, I think, early 2000s. And he took a portfolio that was in a lot of places and really kind of folded it down to very clinically applicable and applicable to the business. And so he's doing a really great job of kind of reining that in so it makes the right impact. And I agree, we share some things in trust. I'll try to have everything protected before I mention it, but we continue to push on those elements. And we believe in the uniqueness of our device and the ability to connect that protection through the things that we already have. I think we, in a lot of cases, have overfiled. And so that's a different type of problem to have because there's residual costs associated with that. But the upside is that you have some coverage in places that you were going to push for anyways. Yeah, thank you for that.
It's hard. We're not hearing you real good, Andrea. I don't know if your audio or your bandwidth is off, but that was good. Eric or John?
So I'm good. I think all of us spine guys had the same question all at once. So that got taken care of. Great presentation. And appreciate it.
Yeah, I'm a kind of a fracture, trauma nerd. I'm just amazed at the technology. It continues to blow my mind as you super smart people figure out how to do things in spine and totals. It just amazes me. I wish I had some great contribution, but I'm happy to be here and be amazed. Very cool.
Yeah, thank you. John, I wish I had a better place to go in fracture work. The fracture work, you got to get the segments unless they're open. It's hard for us. I did see, and I don't know who had it, but I had a pretty good presentation on a reduction robot in fracture work, which I thought was neat in MMVC. But we did a lot of attempts at fractures at Brain Lab with navigation. And the arrays were just very hard to work with. The positioning as you moved it in 3-dimensional. So I wish I had a better solution for that. I don't see us attacking that place soon, but I wish we could find a way.
Well, and I remember at Brain Lab watching and just thinking, how's this going to work? How's it going to happen? And to your point, I think it was, it didn't quite work out the way that we thought. So us trauma guys will just sit in the background and I guess be like carpenters or whatever the heck we are. Anyway, very cool technology.
Yeah, thank you. I appreciate that.
Yeah,
Mark, I think you got your hand up.
Yeah, I just had another question. Outside of your surgeon advisors who will end up probably doing your first cases and all of that, who's going to be, and this might be a question for your marketing team, who are your first customers? Are they 35-year-old right out of fellowship? Are they, who do you think's going to grab onto this early as a general group? Just curious.
Yeah, I happen to have the head of marketing on the call, so I don't know if we'll have some fun and maybe make actually try to answer that. I certainly have a very strong feeling about it. Ashley, do you have any comments?
I do. I suppose this is not something we're not commercialized yet, still not FDA cleared. But certainly when we talk with surgeons, there are different groups that are interested. At this point, we're talking primarily with hip and knee surgeons based on our first venture into robotic knee surgery. And so, of course, we have some surgeons who are at the cutting edge, thinking about how they are advancing robotic knee surgery, total knee surgery to continue to improve outcomes for patients. So some of the surgeons on our design team are certainly at that cutting edge and highly experienced robotic surgery users. But of course, as we think about the potential to simplify robotic surgery and our aim of removing steps and saving time in the procedure, we certainly hope that and intend to show that we can improve the learning curve for new surgeons and certainly also remove some of the barriers. Doug told the story of his dad who had robotic knee surgery and told about the experience. My stepfather just had his second knee replacement, and knowing what I do, asked his surgeon, "Did you use a robot?" And they said, "No, we didn't want to put pins in your legs." And so we are hopeful, of course, that we can enable pinless robotic surgery and remove some of those barriers to adoption. But given our go-to-market strategy, it's very much likely a conversation that we will be having with the partner that we integrate with and who makes sense. I would imagine limited market release starting with those early adopters.
Yeah, Ashley, thank you for that. Mark, I'll answer that kind of in the same vein, but more brief, is that we don't care who gets it first. And we hope that it makes impact for somebody who's been a long time user. What we really hope we capture is the person who, like Ashley's father surgeon, who did not want to do a procedure with a robot because of the pins and now will because there's a better way. So that's the person we like and we'd hope our partners like, but outside of that, we're indifferent.
Seems like the high volume surgeons in like teaching hospitals would be all over this. Mark, does Charlie the cook use a robot when he does 16 knees a day?
Negative.
Okay, that would have been a good one.
Yeah.
We're good.
No. He tends to be a bit dismissive of robots. I'll just put it that way.
Interesting.
Yeah, I'm friends with Charlie and we have some good conversations. He and I have known each other for a while, but yeah, doing a crazy amount of volume. We think that actually this improves volume for those who want to use a robot and helps them save some time.
I mean, yeah, it's got to be. I mean, how many minutes does it take to put place pins or even markers that, and register the thing?
It's not majorly significant in the folks that do it frequently, but the folks that are really streamlined, it's a couple of minutes. We had a company tell us the first time their surgeon does it, the registration alone was 25 minutes, right? So, once you get good, it's like anything else, but registering 25 minutes is untenable for us. We do it 25 times in a second.
Yeah. I mean, it's faster than you can blink. That's incredible. Interesting. What about foot and ankle? I mean, there's not a lot of open procedures there, but
there's not a lot of open procedures. We haven't pushed in foot and ankle just yet. We're looking at all avenues. We've done a lot of work in craniotomies. We actually were born as a company that tracked brain shifts. So if you do craniotomy and the brain floats and moves, we can tell you where the brain moves. So for deep brain stimulation or brain computer interface, we feel very bullish about the application there, and to be able to be very precise in brain surgery. We're looking at hundreds of microns of accuracy. I tell the team 2 millimeters is what the FDA kind of defaults to. And they're like, 2 millimeters, that's miles off. So we're really excited about the accuracy that comes out of the system.
yeah, you remember you telling me the inception of the company was basically, I think there was a professor of optics that was trying to scan his firstborn child, and there was a guy trying to horse breeder scanning his horses for sale, and then they ran into a brain surgeon, and he said, "Hey, when I'm working on the brain, it's Jello. This is exactly what I need." And then it became, let's turn this into a company and try to make it work.
Yeah, it's a pretty good memory, and we kind of cobbled this all together long before I came, and I was excited to be able to join the business about 2.5 years ago, and then become the CEO about 2 years ago, and really work to kind of bring some professionals. Ashley comes from a long time, 25 years in the business, and the head of engineering, which you helped me hire. A long time, maybe 30 years in engineering, and we're really excited to bring some veterans to make this go.
Yeah, this is
Tiger. There's a question from Ann Gutzman in the Q&A. If you open up Q&A.
Yeah. Let me.
Are you getting real-time images, real-time during after resection with your technology? Would you need to make a longer incision in order to expose and track the movement of the femur and tibia post-resection? Some of those parts I can't answer those. Some I can't answer. We don't anticipate a longer incision. The nice thing about knee is you get a pretty good incision. One of the things that we're really proud of is you get a very high density of data through the scanner. So we saw that lamina, very limited exposure on that lamina, and able to create a superposition to the CT. So small incisions are not terrible. It depends on how this is functioning. We don't anticipate a larger incision. And also validating when things are cut, that's a very interesting place for us. You also think about what happens imagine a total knee that's infected, and you'd like to use a robotic system, but you need a CT scan. Well, you don't know how much bone you'll lose when you pull the femur off. And so whatever cement or biologic press fit you've gotten, you can't quantify that. Now you can take the scanner into procedure and say, okay, I've removed the femur. I now know how much bone stock I have, and can now use these systems in a revision scenario where you can identify what the bone loss is. And I think you go a little bit further there. So hopefully that kind of winks at your question without me having to directly answer or give away our secrets.
Yeah, revision procedures are really open, and yeah, you could get great visibility, and they're also very unpredictable. When you remove the original components, you have no idea what you're going to end up with. If you're ice cream cone or a lot of bone.
Yeah, and if you're using a robotic system that requires imaging, then you got all that scatter associated with the retained hardware, And so that creates another level of challenge.
Hmm. I didn't think about it. So this works with metal components in, because
Yeah,
it's just
so-
optical. Yeah.
Yeah, optically looks at all the tissue that can be seen.
And you haven't even talked about this, but there's no radiation either. You're getting perfect
No
visibility.
radiation either, yeah. So it's you saw it, it's in white light or in infrared. Infrared is not penetrable by the OR light, so it's better that way.
Wow. Any before we wrap up, any ask, Doug, any additional ask of the group?
No, I really enjoyed this discussion. My ask is that you follow us, or if you have thoughts, please feel free to reach out. I think it's always nice to connect with a group of peers who are thinking about these problems and challenges. It was nice to hear that a lot of the thoughts were things that I had considered and had a very strong feeling for, and in a lot of cases were supported by you all. So I want to thank you for having me. I think this is a really good group. It was good to see some of you at MMVC. We're pushing like crazy, and we hope that we showed you something special today.
Excellent. Thanks. Great stuff, Doug. Yeah, keep up the strong work. Good luck at AUKUS. And we're gonna see this all over the place next year. It's gonna be fun. All right.
Thank you, Tiger. Have a great day.
Go VIsie.
Thanks, everyone.
Thanks, Ash.